Okay, hi class. We are doing 5.3 right now. So last time we did sine and cosine, but right now there are 6 total trig functions that we want to learn. So we learned sine and cosine based on the unit circle, and we're going to learn the other 4 now. We're going to start with tangent and then learn about what are called the reciprocal ones. So let's start with tangent. The first thing is let's go ahead and define what the other 4 functions are. So remember, on a triangle, sine is so katoa. So sine is opposite over hypotenuse. So sine of an angle is defined as opposite over hypotenuse. Cosine of an angle is defined as adjacent over hypotenuse. Okay, and tangent of theta is defined as opposite over adjacent. Now on the unit circle, remember what that means. So the hypotenuse is always 1. So if you have an angle, draw your right triangle, there's your theta. So opposite is right there, and that's going to equal y. That's the y value. It's right here. That's the length right there. And right here is going to be your adjacent, and that's going to equal x. So every time I see opposite, and also remember we talked about hypotenuse is 1 because it's the unit circle. So replacing that here, we get opposite over hypotenuse, so opposite, so it's going to be y. So it's the y value. This is adjacent over hypotenuse, so it's the x value. Now this is going to be opposite over adjacent, so that's going to be y over x. Okay? And so that's how we're going to define the tangent for the unit circle. Now, so that's the 3 basics: sine, cosine, tangent. Sine, y, cosine, x. Tangent is y over x. The other functions are called the reciprocal functions, and they work like this. Cosecant of theta is defined as 1 over sine of theta, and so that's going to be 1 over y. Secant of theta is defined as 1 over cosine of theta, and so that would be 1 over x. And finally, cotangent of theta, well, that's cosine of theta over sine of theta. It's the same thing as 1 over tangent theta, just FYI. And so that's going to be x over y. So these 6 functions we're going to be using throughout, and they all come back to the unit circle. So if you know your unit circle, you can actually know 6 different functions at each angle. Okay? So for instance, let's take a look. I'm going to try to leave this here so you can look back to it. So here's the point. Negative 3 over root 3 over 2, comma half is on the unit circle. Let's go ahead and plot it first to find out where that angle is. Okay. So here the angle, the x is negative root 3 over 2, the y is half. Okay. Now remember that x is negative over here in quadrant 2 and 3. And so negative root 3 over 2, that means we're going to be either here or here. The second clue is that the y is positive, y is half. So that means y is only positive in quadrant here, quadrant 1, and quadrant 2. So that means the only one that works for this problem is quadrant 2. And I want the y to be half, so that means it's like that. So the y is smaller. So that's my angle, going like that. And so that means that the angle right here that we're looking at is the biggest angle that's still in the second quadrant. So that's 5 pi over 6, or 150 degrees. Okay, so that's just the angle that I'm looking at. Now, the problem wants me to find all the 6 functions right there. Okay, so the way I find that is, okay, sine of that angle, well, that's just going to be the y value, which they gave us was 1/2. Okay. Cosine of the angle, well, that's going to be the x value, which again they gave us was negative root 3 over 2. Okay. And then the tangent of the angle is going to be Well, it's just y over x. That's what the definition of tangent is. It's just the y divided by, it's a ratio of y divided by x. So for us, it's going to be 1/2 over root 3 over 2. Okay? And I can do the simplifying over here, so it's going to be 1/2 times, you flip that, so it's going to be 2 over root 3. And so you get 1 over root 3. Okay, but of course, you know, we don't leave the radicals in the bottom. Okay, we're not savages here. So we have to multiply by root 3 over root 3. It's called rationalize the denominator, and we get root 3 over 3. So that's equal to root 3 over 3. Okay, and then we're going to go ahead and finish out here. We're going to find cosecant. Cosecant of the angle, again, is just the reciprocal of this. It's 1 over y, so it's 1 over 1/2, so that's 2. Secant of theta is equal to 1 over x, so it's going to be 1 over negative root 3 over 2. And so that you're just going to flip that, it's going to be negative 2 over root 3. But again, we don't like to have that radical right there. So what you do for that is, again, just go over here, scratch work, and you get negative 2 over root 3, so it's negative 2 over root 3. You rationalize the denominator, excuse me. And then you get negative 2 root 3 over 3. So that's negative 2 root 3 over 3. And then the last one, cosecant of theta, is going to be the flip. Sorry, I already did cosecant. Cotangent, sorry. The last one is going to be cotangent, which is x over y. So it's going to be root 3 over 2 over half, which becomes root 3. Okay. Now we do have to know our unit circle to be able to do this, because if we try to use our calculator, it's not going to give us an exact answer. And I want exact answers because we're going to use these. You can use these in calculus, and you need to know the exact answers, not just the decimals. So for instance, like I figured out the angle was 5 pi over 6. And I make sure my mode is right. I'll go to radian. So for instance, when I do, you know, like cosine of 5 pi over 6, oops, excuse me, 5 pi divided by 6, okay, it just gives me that, negative 0.866025. Now I don't know what that is. That's just a decimal, and if you tell me that shows me that you didn't actually get the exact answer. So I want exact answers. Now it turns out that is negative root 3 divided by 2. But again, you have to know that. So you have to be able to know your unit circle to be able to get these answers. I will not accept, just, you know, make a note of it, okay? I will not accept approximate answers, okay? So I'll write that in red. I will only accept exact answers. So that what I mean by exact is I want you to show me that it's, you know, root 3 over 2 or root 2 over 2 or stuff like that, you know, not just plug it into your calculator and getting a decimal. So decimals are not appropriate. Okay, so let's finish up with this one. Find all trig functions when the angle is pi over 2. So again, we have our angle here. Let's use our unit circle first. So pi over 2, remember, is 90 degrees. So if I plotted that, that's the angle right there, which is a 90 degrees, so pi over 2. All right, and so I'm going to go ahead and find those. So do sine first. We can do cosine first, doesn't matter. Okay, so cosine of pi over 2. Let's go ahead and label that point right there. So that point right there, sorry I didn't leave enough room, but the point that's right there, remember that is going to be Well, the x is 0 and the y is 1. So cosine of pi over 2 is what the x value is, so that's 0. Cosine of pi over 2 is 0. Sine of pi over 2, well, that's the y value, so that's 1. Tangent now, remember what that's going to be. That's going to be sine over cosine. It's going to be y over x. So it's going to be 1 divided by 0. Uh-oh. Well, remember, you can never divide by 0. So 1 divided by 0 is not defined. So we actually just say that's undefined. So tangent of pi over 2 is undefined. There's nothing we can do. And so please don't call it 0, don't call it infinity, just say, don't even leave it as 1 over 0. 1 over 0 is not defined, so we just have to say it's undefined. And so then we have secant with pi over 2. Remember, that's 1 over the cosine value, so that's 1 over the x, which is 0, so again, that's also undefined. And then cosecant of pi over 2, that's going to be 1 over the y value, 1 over 1. And so that's 1. And then finally, cotangent of pi over 2. That's going to be defined as the x over y, which is 0 over 1. And so that's going to be 0. Okay? Again, if you try to rely on your calculator here, for some of these angles it will work. So for instance, cosine of pi over 2. Okay, that's 0. And it'll do the same thing for sine of pi over 2. But if you do tangent right here, tangent of pi over 2, it will say undefined. So for those domains, yeah, it means it's undefined. So, but I don't want you to rely on your calculator, because your calculator is just going to give you a decimal answer. You need to be able to actually do it, using your unit circle and going from there and being able to write them out. It's really going to help you in calculus too, because calculus, you're going to have to use these trig values all the time in the middle of a problem. So you want to know those cold so that you don't have to go back and think, oh, what's this again? Okay. All right. Oh, and one thing is that if you are going to use your calculator just to kind of give you a sanity check, so if your calculator only has the 3 functions, sine, cosine, and tangent, okay? It doesn't have cosecant, secant, and cotangent. Well, how do you find cosecant? Well, remember, cosecant is defined as 1 over sine. So if you wanted to do cosecant, so for instance, like right here, if I wanted to do cosecant of pi over 2, I would do 1 divided by, so if I want to do cosecant, it would be sine. So 1 divided by sine, for instance, pi over 2. So that's how you would do the cosecant and secant and cotangent. All right. So it can seem like a lot of work to have to know how to do all these stuff, because on the unit circle there is, if I draw my unit circle right here, there's an angle here, 0, and there's an angle here, pi over 6. There's an angle here, pi over 4. There's an angle here, pi over 3. And there's an angle here, pi over 2. And then there's all these angles too, 2 pi over 3, 3 pi over 4, 5 pi over 6. So it can just take forever. It can seem overwhelming. And for each of those angles, there's 6. There's like, I have to count actually. There's how many angles that we can have? There's 3, 6, 9, 12, 16. So there's 16 angles that we'll look at, and there are 6 trig functions for every angle. So that makes 96 pieces of information that we'll have to know. That's impossible. So don't think you have to do that. What I'm going to always do is just be able to know the first quadrant. And if I know the first quadrant, and all I have to know is, so you only have to know 3 angles in the first quadrant, quadrant 1. So this is all you have to know, is these 3 angles and sine and cosine there. So you really only have to know 6 things. If you know 6 pieces of information, then you're going to be good to go. You can do the rest. So how cool is that? So you only have to really know 6 things rather than 96. Okay? So for instance, I'll give you an example. So here for negative 5 pi over 6. Now, I could just like have that in my back pocket, and I could remember what negative 5 pi over 6, all the 6 angles, all the 6 trig things are. But, you know, forget that. Bump that. There's too much stuff that I have to know. Instead, I'm going to plot the angle first. So the first step is you want to plot the angle. So first step, plot the angle. Negative 5 pi over 6. Well, here's 0. Negative's going this way. This is negative pi, which is negative 6 pi over 6, the 180 degrees. And so it must be the angle right here. The angle is real small right next to it. And so that means that that is my angle. And so that's negative 5 pi over 6. Okay. Now the cool thing is we were talking about reference angles. All you have to know is that, okay, its reference angle, I'll draw that in blue, is right here. So why don't we draw the reference angle first and just display the information. So this angle is small. It's small, and so that means the sine is small. So it's going to be 1/2. And the angle is going to be big. The x is going to be big. Now what's cool about that is that all you have to know then, let me make that in red here. All you have to know is that these are going to be the same values, it's just off by a negative sign. So let's think about, in this quadrant, this is quadrant 3. The x is going to have to be negative because the x is negative, so it's negative root 3 over 2. Okay, and the y value is also going to be negative because they're both negative down here. So it's negative 1/2. Okay, with that information, I can now do sine, I can now do secant, cosecant, and all that. So pretty cool. I only had to really know this and how to draw my reference angle. From then on, I can do the rest. So I know that cosine of that angle of negative 5 pi over 6, I now know it's negative root 3 over 2. Sine of negative 5 pi over 6 is negative 1/2. Tangent of negative 5 pi over 6. Okay, well that's going to be y over x, so it's going to be negative 1/2 divided by negative root 3 over 2, which again I'll do over here, so I need to simplify that. Let me get rid of this. So it's going to be, okay, my computer is acting up again. Okay, hold on, I'm going to pause the video. Okay, we're back. Sorry, my computer's acting weird. Okay, so then let's finish this up. So negative 1/2 over negative root 3 over 2. That's the same thing as negative 1/2 times 2 over root 3, negative. The negatives cancel out, and the 2's cancel, and so we're going to be left with 1 over root 3, which again, you know, we have to rationalize. We're not savages here. So we get root 3 over 3. And so this is equal to root 3 over 3. Okay? So that's how that works. Now, the way we find the other ones, cosecant, secant, cotangent, we just take their reciprocals. So that's all. So so I know secant is just going to be the flip of that, of cosine. And so it's going to be negative 2 over root 3, which we have to rationalize, and that becomes negative 2 root 3 over 3. Cosecant of negative 5 pi over 6. Again, it's just the reciprocal. So I've been doing it as x over y or y over x or 1 over y, 1 over x. Also mathematically, it's just 1 over this. So it's going to be the reciprocal of negative 1/2, which is negative 2. And cotangent is going to be the reciprocal of this, which would be 3 over root 3, which will, you know, rationalize and that will become just become root 3. Okay. All right. All right. I think I'm going to quickly do this one with not so much explanation. No, I think we have time. I know these videos are getting a little longer than what I had hoped for. I'd hoped for be about 30 minutes. They're getting a little long, but thanks for your patience. So let's go ahead and do this one. Typically, just to let you know how the sausage is made, is I would have students do some of these in class, so that's why it's taking a little long, because I'm doing them all, but that's all right. So let's go ahead and evaluate this guy. So again, the first step you want to do is always graph your angle. Draw your unit circle, plot your angle. And so negative 7 pi over 4, that's going to be, well, pi over 4 is really easy. They're always in the middle. They're due in the middle. Now, this is negative, so I need to go opposite. So I start here. That's 1 pi over 4, a negative. That's negative 2 pi over 4. That's negative 3 pi over 4. Negative 4, negative 5, negative 6, negative 7. So negative 7 pi over 4 is right here. It's all the way around. And so this actually is in the first quadrant. So that's nice. So I just have to use the first quadrant knowledge that I have to know that at pi over 4, the x, they're both the same. It's root 2 over 2 and root 2 over 2. So that's nice. And so now when I want to do, cosine of that angle, I'm just going to call it theta for now, because it's tedious to have to write it over and over again. We get root 2 over 2 sine of theta. We get root 2 over 2. Now tangent, again, that's going to be y over x, so it's going to be root 2 over 2 over root 2 over 2 y over x. But these are the same values, so they cancel out and they just equal 1. So that's nice. That's a good thing to know. At the 45-degree angles, at pi over 4s, tangent is always 1. It might be negative 1 or 1, depending on what quadrant it's in. Okay, and then we go here, and we go to secant. Secant of theta here is going to be the reciprocal of this. It will be 2 over root 2, which, again, we rationalize. We're not savages here, so we're civilized folk. So we get 2 root 2 over 2, so it's just root 2. Okay? Cosecant of theta is going to be the same thing. It's going to be 2 over root 2, which will equal root 2. And cotangent is just going to be 1 over 1. Just 1. Okay? So make sure that you know the process. Draw your angle, draw the circle, draw your angle, write out the x's and the y's first, and then using your reference angles if you need to, and make sure you have positive and negative correctly, and then just go from there. And so really just you have to remember what they're defined as. Sine is the y, so remembering this is important. Sine is the y, cosine is the x, tangent is y over x, and then the reciprocals. Secant is 1 over x, cosecant is 1 over y, etc. Okay? So we're going to finish up here. Why is there 4 pages here? Okay, yeah, so we're going to have to move along here. So, so the function's even, so we're moving on. Weird transition here. The function is even if, we talked about that a little bit at the beginning of this semester. The function is even if you plug in negative x, then you just get f of x. So negatives don't make a difference. And remember that what that looked like is symmetrical across the y-axis. And odd is if you plug it in negative x and you get negative f of x. So the two functions that are even are cosine and secant. So those are even. So what that means is that cosine of a negative angle is the same thing as cosine of x. Same thing with secant. And these guys, the rest of them are odd. So what that means is, for instance, sine of negative x is actually equal to negative sine of x. So that's kind of cool. So what that means is that if you don't want to deal with negative angles, you can just look at the positive angle, you know. So the unit circle tells us why, because if you look at, just pick a random angle, like, I don't know, pi over 3, and look at negative pi over 3, the cosine is the same. So this is pi over 3, this is negative pi over 3, and the cosine is going to have the same x value. It's just right here, it's connected by that line. And it's the same thing for other angles, like if I do pi over 6 and sorry, negative pi over 6, then the y values are opposite. Okay. So just the thing to remember is that cosine and secant are even, and all the rest are odd. Okay, so let's go ahead and get started here. So when we're evaluating tangent of 45 or negative 45, the thing to remember is that tangent of a negative angle is the same thing as negative tangent of 45. So if you just know the tangent of the positive angle, then you're going to be good to go. So let's just work on the tangent of the 45. Now 45, again, remember where that is. That's right here. Okay, and that's root 2 over 2 and root 2 over 2. So that means tangent there is just going to be root 2 over 2 divided by root 2 over 2. Remember, it's y over x, and so that's 1. And so that means tangent of negative 45 is just going to be, according to that identity, is just going to equal negative tangent of 45, which we just said was 1. So it's going to equal negative 1. Okay? And it makes sense because down here is the negative 45. The y is negative there. Okay? Secant, now secant is even, so what that means is secant of a negative angle of negative 5 pi over 6 is the same thing as secant of 5 pi over 6. So we really only have to look at the positive angle. So we really just got to do secant of 5 pi over 6. It's going to be the same answer as that. So I'll draw my unit circle. 5 pi over 6, well, we did that earlier today. That was over here. It's the angle right before 6 pi over 6. So that's 5 pi over 6. And so the x values here, again, the angle is close to the height is close to being 0, so it's 1/2, and it's positive. And in this quadrant, the x is negative. Oh, sorry, I messed that up. The y is 1/2. So the x is negative root 3 over 2, and the y is 1/2. So what that means is that secant is 1 over the x value. So secant of 5 pi over 6 is going to be the reciprocal of root 3 over 2, which is negative 2 over root 3, which again will simplify, will rationalize. And that's going to be negative 2 root 3 over 3. Okay? And again, knowing that identity, I know that that's going to be exactly the same thing. It's going to be negative 2 root 3 over 3. Okay, and the reason for that is that negative 5 pi over 6 is over here, and it's going to have the same secant value because the x is the same value right there. Okay. So now we're going to get a little bit of taste of what we're going to be doing next chapter. We can do some algebra to simplify this identity. So secant over tangent, that seems really complicated. Like if I asked you to define secant over tangent of an angle, it'd take a lot of work. But we can simplify this because I know secant is 1 over cosine. And so let me write that as, so secant of an angle divided by tangent of an angle. I know secant is 1 divided by cosine. And I know tangent is sine over cosine. Okay, so there in this first step on the top, I rewrote secant as 1 over cosine because that's what it's defined as. And tangent, one definition for it is it's sine over cosine. So, because it's y over x, right? Remember, y over x, and this is 1 over x. So that's why we're able to do that. So, now that I do that, I just do my algebra, I know I can flip this bottom on top, and that becomes cosine of t over sine of t. And the cosines cancel out. And so now I'm left with 1 divided by sine of t, which I know is, remember what 1 divided by sine is? That's cosecant. So if you ever had to do a problem where you had to do secant divided by tan, you know you can actually just do cosecant, because it's the same thing. And we'll do one more, tangent times cosine. Well, tangent is just, you know, a reminder, tangent is sine over cosine. And we're multiplying by cosine. So again, this was just using the identity that I talked about. Tangent is defined as sine over cosine. It's y over x. And so the cosines cancel out, and I'm left with sine. Okay? All right. All right, so last little step here. We had this Pythagorean identity last time. Sine squared plus cosine squared is equal to 1 on the unit circle. Again, that's because the radius is 1. So this is the x, this is y. But y is also sine. So x squared plus y squared equals 1, equals the hypotenuse, which is 1 squared. So I just want to show you that we can rewrite this using a bunch of algebra to get different identities. So starting with this, we could subtract sine squared from both sides. So our next identity, I'll write it over here, is that cosine squared of t is the same thing as 1 minus sine squared of t. Okay? Number 2 is we can do the same thing, but rather than subtracting sine squared, we can just subtract cosine. So if I subtract cosine squared of t, then we get sine squared of t is equal to 1 minus cosine squared of t. Okay, so those are two identities that we can get just from doing that. But we can get a few more, and I'm just going to we can get two more that I want to write. Is if rather than subtracting, if we divide by sine squared, so divide everything, left side and right side by sine squared, then we get the following identities. Sine squared divided by sine squared, that's going to equal 1. Cosine squared divided by sine squared, well, remember cosine over sine, that's the opposite of tangent, so that's going to be cotangent, so plus cotangent squared of t. And 1 divided by sine squared, well, remember what 1 divided by sine is. 1 divided by sine is the reciprocal of sine, which is called cosecant. So that's going to be cosecant squared. Like that. And so that's our next identity. That, I'll write cosecant first. Cosecant squared of t is equal to 1 plus cotangent squared of t. Okay? And so this one I divided by sine. Obviously the next thing I could do is, let's see what happens when I divide by cosine squared. Okay, and so if I divide by cosine squared of t on both sides, then what happens? So sine squared divided by cosine squared, that's sine over cosine, which we said, remember, sine over cosine is tangent. And so that's going to be tangent squared right here. And then here it's just going to be cosine squared divided by cosine squared, so it's going to be plus 1. And that means it's going to equal 1 divided by cosine. Remember, 1 divided by cosine is the reciprocal of cosine, which is defined as secant of t. And so we get secant squared of t is equal to 1 plus tangent squared. Okay, so those are our 4 extra identities that we can get from the Pythagorean identity. Now the good thing is that it can be very difficult to, well, let me get to the good news. The good news is that we don't really have to memorize these 4 new ones, because if we know that first one, the Pythagorean identity, we can get all the rest of them. So if you just know this, oops, I need my pen. If you just know this, then you can get all these 4 whenever you need. So I don't recommend memorizing these ones so much as just for memorizing this. This is like the granddaddy or the grandmama of all the identities, and you can just get these later. So it's just like in the unit circle. Just know your first quadrant, you can know the rest. Okay, just know this first identity, and you can get all the others. All right, well, we can use that identity for this problem. So it says cosine of t is equal to 12 over 13, and the angle is in quadrant 4. All right, so again, draw your unit circle. All I know is that the angle is in quadrant 4, so it's like here somewhere. I don't know what the angle is. Okay, and so it went around like that. Now, let me write out what the values are here. I don't know what the x and the y values are, but I can at least say if they're positive or negative. In this quadrant, in quadrant 4, that tells me that the x value is going to be positive, and that tells me that the y value is going to be negative. So that's really all I need for quadrant 4 for. And well, we can find the other values, because if cosine of t is that, I'm going to use the Pythagorean identity. So let's use the Pythagorean identity. So remember what that said. That said cosine squared of an angle plus sine squared of an angle is equal to 1. So I know cosine of t, so I'm going to plug that in. So it's going to be 12 over 13. That's cosine. I have to square it. Okay, plus sine squared of t. Okay, that has to equal 1. All right, so then we can actually solve for what sine is, because I can subtract 12 over 13 squared from both sides. So now I have sine squared of t is equal to 1 minus 12 over 13 squared, which I want to do. I want to get that fraction, so I'll do that over here. This is going to be 1, take away 144 over 169, which will be 169 minus 144, which is going to be 25 over 169. Okay, so I found out now that sine squared of t is equal to 25 over 169. And I wanted to find out the trig function, so I wanted to find out what is, sine of t, what's tangent of t, etc. So if I square root both sides, that tells me that sine of t is equal to the square root of 25 is 5, and the square root of 169 is 13. Now the question is, remember, when we do the square root, we have to pick up plus minus. So are we going to take the positive answer or the negative answer? That's why I did this. Remember, this is the y value, this is the sine, and this is the x is the cosine. So y is the sine, so that tells me that, oh, it was negative in this quadrant, so this answer is going to be negative. So that's why we have to know which quadrant it's in. Okay, so now I know that sine is negative 5 over 13, and now I know cosine. I'm just going to make a little, I'll write it over here. So now that I know cosine of t is 12 over 13, I know sine of t is negative 5 over 13. Guess what? Even though I don't know the angle, I have all my building blocks to be able to find out what tangent is, because now I know tangent is just going to be the y over the x. It's going to be sine over cosine. So it's going to be negative 5 over 13 divided by 12 over 13, which will equal negative 5 over 12. Okay? And I can find the others as well. I can find secant and cosecant, because secant is just going to be the flip of this. It's going to be the flip of cosine. So secant of t will just be 13 over 12. Cosecant will be the flip of sine, which will be negative 13 over 5. And cotangent, sorry I ran out of room. Cotangent will be the flip of tangent, so it will be negative 12 over 5. Okay, so pretty rad. I didn't even know what the angle was. I didn't need to know the angle. Okay, so that's it. Thanks for sticking along. It's a long lesson, I know. These get longer and longer, but I appreciate it, and have fun on the homework, and I'll see you next time.